about what, voice is off. Let's talk about what substitution means. What does the word substitution mean in general?
It means it's something you fill in a place that doesn't have it.
You're taking the place of something,
Yeah.
right?
Yeah,
So when I'm gone, right, there's a substitute teacher. If you play sports, you substitute in and out so you're not playing the entire game, right? You can substitute ingredients for recipes. If you don't like something, you take it out. Maybe you add something you do like, right? There's all sorts of things. Like, for example, oatmeal raisin cookies. I hate raisins, so I will take out the raisins and I will add chocolate chips. So then I have oatmeal chocolate chip cookies, which are delicious, right? Life-changing. Yeah. So what we're doing today is we are talking about how to solve a system. Remember, a system is two equations where we're trying to find where they would intersect on a graph. So we have the same goal, right, that we had when we were doing graphing. We're going to try to determine the ordered pair that works for both equations. Okay, we're still trying to find that ordered pair. We're not going to be graphing for this. We're just going to use substitution. There are going to be some equations where you're going to be like, oh, I wish I could graph. It's not going to be pretty because sometimes you get awkward y-intercepts or strange slopes. So we're going to start out kind of simple, and then we're going to progressively get a little more difficult, but I think you guys will be okay. Because as long as you keep in mind that we are substituting, we are putting something in the place of something else. So we have these two equations. Y equals negative 2x minus 9. 6x minus 5y equals negative 19. So what we have to decide, the first thing we want to look at these two systems and we want to decide, are either of them already having a variable isolated? Do either of these equations have a variable that's already by itself? Which one? Stella? Yeah. Y equals negative 2x minus 9. So if you already have a variable that's isolated, that's half the battle. Just figuring out what one of these variables equals, right? So because we know what y equals, let's go ahead and highlight that with our yellow pencil. We know that y equals this expression. I can take that expression and use it in the second equation where y is. Okay? So I'm going to rewrite this equation with this, negative 2x minus 9, taking the place of y. So I want everybody to put your pencils down, look, listen, learn. Because this is kind of, everyone's like, oh yeah, that's easy. And then they look down and look up and they're like, I don't know what you did. Okay? So we're going to take this 6x minus 5 times the quantity negative 2x minus 9 equals negative 19. I put this expression where y was. Okay? Because I know that that's what y equals. So I took this expression and I put it in this equation exactly where y was. Go ahead and do that now.
Do you have like a pencil sharpener that's deep?
It's fine, you can use a loud one. Yeah.
What is it about correct company?
Oh, yeah, that's just a typo from the study guide. Remember, this is now 12 p.m., right? It's okay. Okay, so what I have now is an equation with one variable. This whole equation only has x's. And we all agree that now we have no y's left here. So what I can do is I can solve for x. So I'm going to go ahead and solve for x. I'm going to have 6x. I'm going to distribute this entire negative 5. So I'm going to have plus 10x plus 45 equals negative 19. And then I'm going to use my powers of equation solving. Some of us need our wall of equality. I'm going to have 16x plus 45 equals negative 19. Subtract 45 from both sides. 16x equals negative 64. And I find out that x equals negative 4. So this is going to be the x value of my solution, right? Because we're trying to find that ordered pair that will work for both equations. So I took what I knew y equaled, I put it into the other equation, solved for x, so now I have the x value of my solution. How am I going to find the y value? Melissa? I'm going to put that negative 4, I'm going to substitute it back into one of the original equations. It truly does not matter which one. However, I'm always looking for the easiest. Okay? So when I look at those two original equations, which one looks like it'd be easier to solve if I put negative 4 in for x? Cam? The first one. Right? I don't want to deal with all of this situation here. So I'm just going to put that negative 4 in for this x. So I'm going to substitute the negative 4 back into one of the original equations. And I think we can all agree with Cam that that first one's going to be easier if we just put that negative 4 in there. So I'm going to have y equals negative 2x minus 9. Y equals negative 2 times negative 4 minus 9. And I find out that y equals negative 1. So what is my solution to this system of equations, Logan?
Negative 4, negative 1.
Yep. So what that means is if I were to graph both of those original equations, where will the two lines intersect? Alice? Negative 4, negative 1. Yes, Augie.
And if you put both those values into the bottom equation, they also still equal negative 19.
Yep. Right? So what we're doing is we are making sure it works, right? If we were to graph it But I think this is going to get kind of ugly here because I would have to subtract 6x, then I'd have to divide by -5, and then I'd have to graph it and hope that my increments match up, and it could be a lot of guesswork, right? So substitution is often the choice when you don't have a way to graph it, or you don't think the graph would be easy. Thank you, sir. Okay, I'm going to go on to my second page. This next one's going to take up some room as well, so I would suggest you go on to the second page. Yes, sure thing. What is different about these two equations from the first one we did? What is different, Joey? We don't have an isolated variable. So we have to isolate a variable. Right? And this is where it's like choose your own adventure. What is choose your own adventure? What is that, Alice? Exactly, right? Turn to this page if you think this should happen. Turn to this page and you can have like a bajillion different combinations to make up a story, right? So if we're going to choose our own adventure, we're going to look at these two equations and we're going to decide which one is going to be easier to isolate a variable. What you think is easy, I might not think is the easiest choice. And what I think is easy, you might not think is the easiest choice. So this is where we part ways sometimes. But as long as we get the same answer, I'm fine with that. I don't want you guys to be a mind reader and try to figure out which one I would do. Okay? So for me, I'm going to subtract y over here. And I'm going to get x by itself. Because all I see here is fractions. If I divide everything by 3 up here, I'm going to end up with fractions. I don't love fractions, right? So I'm going to do x plus y equals -2. I'm going to subtract y from both sides. And now I have x equals -2 minus y. So now I have an isolated variable, and I can use that in the equation. Notice that I got x by itself. The first one was easy, we had y. It does not matter which one you choose to isolate. You're going to find that value, put it back into the equation to find the one you didn't do. So now I'm going to have to make another decision. See what I mean by choose your own adventure? Where do I want to put that -2 minus y? Do I want to put it up here in this first one, or do I want to put it down here to take the place of x? Which one would you do? Porter's saying the second one. I agree with Porter, right? So what I'm going to do is I'm going to have x plus y equals -2. I'm going to put -2 minus y plus y equals -2. Is that going to work? I feel like that's not going to work. Why isn't that going to work? Hi, thank you. Did I do something wrong here?
No, I think Porter just chose the wrong one.
No, it should still work.
This Porter guy definitely got it wrong.
I'm sorry? Right, but like when I put this in here, I shouldn't end up with -2 equals -2. I should get y by itself.
Wouldn't it be 3?
So the y's cancel out. That can't be right.
If the teacher can't do it, then we can't do it.
Well, no, I'm just trying to figure out like why.
The question is,
I'm not a good bro. This guy here. My fault, your fault. Sometimes I just like
That's what I did.
Yeah, I know the first one works, but why wouldn't the second one work?
Second one should work.
It should. Okay, for the sake of this note-taking experience, let's do the first one because I know that works, and we'll come back to and I'll figure out why the second one wasn't working. I'm gonna spend my lunch figuring that out. It's gonna drive me crazy.
Your poor lunch detention.
Yeah, or you get it.
No, but Porter was right. That's what I would have chosen too, but I just can't figure out why it's not working.
Porter should figure it out.
So once I put this in for x, I distribute, and I get -6 minus 6y equals y minus 2. This should be minus 3y. Then I'm going to add the 3y to both sides. So I have -6 equals 4y minus 2. Then I'm going to add the 2 to both sides. So now I have -4 equals 4y. So I have my y value. And then I'm going to take that y value and I'm going to choose an equation to put it into. So I'm going to do x minus or plus y equals -2. This turns into x minus 1 equals -2. Yes.
This desk is like, so much random stuff in it. Like, it has so many wrappers in it.
I just found 3 rulers in the desk.
3 rulers?
Yeah.
Neat. It's like a treasure chest. Okay, I'll clean it out during lunch. After I figure out what's wrong with that math problem.
I was about to say, you're having a busy lunch.
I do have busy lunch.
Doing over there.
Okay.
How's your face over there?
So can someone tell me why this just became -1 instead of plus -1? Why, Alice? Yeah, right? So it's just, you drop the positive, it becomes negative. Add the 1 to both sides. X equals -1. So our solution is -1, -1. Thank you very much, sir. I appreciate it.
Now we should do some on our own.
You want to try this one on your own?
Yeah.
Okay. Choose your own adventure. We have a good start on this one? All right, somebody tell me which variable did you isolate first? We'll get started on that and then I'll leave you alone. Stella? Hmm? Okay, so how did you isolate that?
I turned it into y equals 4, and then so I made y equals 5x minus 4, and then I put it into other color.
Okay, the only trick with that is that when you subtract the 5x over, did you divide everything by -1? You did, okay. So did everyone hear what Stella did? So she changed this into opposite y equals -5x minus 4, divide by -1 for everything. So she had y equals 5x plus 4. So she got this isolated variable. Did anybody isolate x? What did you do for that?
Basically the same thing. I added 6y to 5.
Yep, and then you just had x equals 6y plus 5? Perfect. Okay? Both ways are fine. You're still going to get the same solution. And I figured out what mistake I made with that the other one. Do you want to hear it? Okay. And I should have known this was going to happen because I'm a math teacher. Tommy?
I'm like very confused.
I know, that's because you weren't here for like the original instructions, so that's why I'm making a video for you guys. Yep. So I will post a video on Canvas once we're done. I'll have to upload it to YouTube and then let it do all of its stuff, and then I'll put it on the Canvas. Okay. All right, so here's what I did wrong up here. And I don't know why it wasn't clicking. If I rearrange this and then I put it right back in there, it's still the same equation, right? So whichever one you decide to rearrange, you have to put it in the other equation. Right? I can't just put a rearranged equation back into original. It's just going to be then infinite, right? That's what was happening, -2 equals -2. So whichever one you rearrange, you have to put it into the opposite. So because I rearranged this one, I have to put this into the first equation. And if you rearrange the first one, you have to put it into the second one. Otherwise, you're going to end up with infinite solutions. And that's not what we're going for. It's okay if you're just, I figured it out. Now I have more time for lunch. Now I got to clean out that desk. That's all I have as a chore. Okay. So because I rearranged this one, I'm going to put this y equals right here. And don't forget this is a -6 being distributed. But Carter, however you worked yours out, just you don't have to change it. You can just keep going through what you were doing. Okay. Got the same answer? Mm-hmm. Sorry, this is not a negative 5. This is just a positive 5. It's supposed to be a 5. Yeah. So I love these pencils, but the erasers are less than awesome.
Brady paid attention.
You don't? Okay. All right, so what am I going to do with this X? Stella.
Put it-
You're gonna plug it back into 5x minus y.
Whichever one's going to be easier for you, right? We're going to put it either into the first one or the second one, whichever one makes more sense to you. Stella likes the second one, so we'll go with that. 5x minus y equals negative 4. And we end up with the exact same solution. There's a reason that's the exact same solution. Because you're going to do a practice page now
Oh crap.
where you're going to have a partner and you're going to have different systems to solve, but your answers should match. Okay? So we all just did number 1 for partner 1 and number 1 for partner 2 in your notes. That's why they match,
Like an escape room.
right? So you're going to work on these. And I'm not going to put you necessarily with someone who has your paper or doesn't. It doesn't matter.
I wanna be with
Them out.
somebody smart. I need to be with somebody smart.
Right now we're just working. We're not even with a partner at this point. You're just gonna work and then I'll say find somebody that has the different page than you and compare your answers.
No.
Okay?
When do
Flip flop.